You know, when you use something like ChatGPT, it feels like it just appeared, right? Like some kind of magic that came out of nowhere. But it wasn't magic. It was a revolution, a lightning-fast series of breakthroughs. So in this explainer, we're going to trace the exact steps, the key papers, the critical ideas, and the intense rivalries that took us from clunky old chatbots to incredible conversational AI in just 3 short years. I mean, it's the ultimate challenge, isn't it? How do you teach a machine, something that thinks in ones and zeros, to get the nuance, the sarcasm, the beautiful messiness of how we actually talk? Let's break down the dominoes that had to fall one by one to make it all happen. Okay, so before we get to the cool stuff, the breakthroughs, we gotta talk about the huge wall researchers were running into. The core problem wasn't just about needing more powerful computers. It was about cracking the fundamental code of how we communicate. First up, we need to get on the same page about natural language. This isn't computer code we're talking about. It's the language you use in your texts, with all its inside jokes and weird slang. It's ambiguous, it's emotional, and it's always changing. And teaching a computer to navigate this beautiful chaos, well, that's the whole ballgame. Right, and the field that tackles this is called natural language processing, or NLP for short. The goal here is to get a computer to not just scan the words you type, but to actually understand what the words mean, you know? So it can do useful stuff like answer your questions, summarize a long article, or even translate between languages. So here was the big roadblock for the early models. For starters, they had the memory of a goldfish. Seriously. An AI could forget what the beginning of a long sentence was about by the time it got to the end. And second, they read so slowly, like one word at a time. It made training them take forever. The goal was to build something that could read everything at once and get the full context, the whole picture. And that brings us to the moment everything changed. The one big idea that kicked off this whole revolution and the race to the AI we have today. This is it. The title of a research paper from Google back in 2017. It sounds so simple, right? Almost poetic. But the idea inside, it was probably one of the biggest leaps forward in AI history. This paper, right here, lit the fuse on everything that was to come. So what this paper gave us was something called the transformer architecture. The secret sauce was a mechanism called self-attention. Just imagine an AI reading a whole sentence at once and instantly seeing how all the words relate to each other. Like in the sentence, the cat sat on the mat, so I petted it, self-attention lets the AI instantly know that it refers to the cat. It just gets it. So by seeing everything at once, it fixed the memory problem and the speed problem. Boom. This was the key that unlocked the whole thing. Okay, so once the transformer was out there, the floodgates just burst open. What happened next wasn't just progress, it was an all-out sprint. A wild race between all the big players to build on this new idea. And a huge concept that fueled this race was transfer learning. And honestly, the idea is pretty simple. Instead of teaching an AI from scratch every single time, you first train it on a massive amount of text, like pretty much the whole internet, so it gets a general understanding of language. Then you fine-tune it for a specific job. Think of it like this. It's like a med student learning everything about the human body before they decide to specialize in, say, heart surgery. It's just way, way more efficient. And boy, was the race on. In May 2018, a LimFit showed that transfer learning was definitely the way to go. Just a few months later, Google dropped BERT. This was a huge leap because it could understand a sentence by reading it forwards and backwards at the same time, finally getting that a word's meaning depends on what comes before and after it. Then early 2019 was an explosion with Google's Transformer XL and OpenAI's GPT-2, which honestly kind of freaked everyone out with how good it was at writing human-sounding text. And hey, here's a fun little tidbit for you. It turns out while these researchers were building these incredibly complex AIs, they had a bit of a sense of humor. Many of the most famous models from this era, like Bert and Ernie, were actually named after characters from Sesame Street. And the pace just kept getting faster. I mean, it was insane. The summer of 2019 was just a total whirlwind. We saw XLNet, then Baidu's Ernie, which leapfrogged competition. Facebook AI dropped Roberta, which was an even better version of BERT, and then another model that could handle nearly 100 different languages. It was just a total explosion of innovation month after month. So all this crazy innovation, all this competition between the big labs, it was all building towards something huge. It was leading to a monumental shift in sheer scale that would directly pave the way for the tools we're all using today. And that brings us to June 2020, and to one absolutely massive number. 175 billion. That's the number of parameters in OpenAI's GPT-3. Now, you can think of a parameter as kind of like a connection in a brain. More connections, more complex thoughts. Well, GPT-3 had 100 times more of these connections than the model that came before it. 100 times. This wasn't just another step up. No, this was a jump to a completely different league, a new level of intelligence that just reset the bar for what AI could do. So think about that. From that one groundbreaking paper in 2017 to the massive scale of GPT-3 in 2020, this entire revolution happened in just 3 years. It completely changed our relationship with technology. Which leaves us with one last really fascinating question to think about. If that's what happened in the last 3 years, what in the world is going to happen in the next 3?